Kia ora team, so I have something quite cool to show you today. This is a circa mid-1950s hand-built in New Zealand Gloria AM radio. So if we turn it around to the back, you can see first of all, manufactured by Dominion Radio and Electrical Corp Limited, Otahuhu, Auckland. We can see the antenna here and the valves obviously across here. 1, 2, 3, 4, 5 valves. Some kind of transformer in here, and some kind of, in here behind the dial, there's some kind of big potentiometer or some kind of, that's the tuning system, is all electromechanical in here. Here we go, here's our adjusting our tuning. I think this is some kind of tone. And one of these, maybe this one. Oh, that's quite stiff, so we'll have to check that out too. In the current electrical environment, essentially, there's a lot of amplitude modulation signals come in over the electrical grid, and all of those get passed straight through this device and get broadcast straight out the speaker. So when you turn it on, it's a thoroughly unpleasant listening experience. However, if we install one little modern component, this is going to act as a filtering capacitor, and this is going to filter out that noise, hopefully. So we're going to first of all see if this even still works, and then we're going to open it up, check this knob, and install this capacitor. So I have connected the Gloria to the power. Now stand back, I'm arming the nugget. So we have some signs of life. We've got, don't know if you can see it, but there's some light in the display here, and if I turn, so you can hear she's picking up stations, happen to be tuned to one in fact, but you can hear that constant whine of other electrical noise. Part of that will be the fact that we don't have the full antenna installed. It's got a bundle of wire to act as its antenna. This is some kind of high pass, low pass filter. We'll have to investigate that. It does a good job of... Or is it a fine tuning? So yeah, she still works. I'm going to slide the components out here, and we're going to investigate what's inside, see if we can reverse engineer it somewhat. So she's pretty simple construction. We've got this big metal component with the valves and electronic components installed on it, and just one screw. There should have been two, and then it slides back. So I have assembled all of the tools necessary for this job. Got some penetrating oil if we end up needing it. I'm going to try find the right bit to get these off. This looks like the one. It's going to be a very delicate operation because these are some old screws. We don't want to bend or break the thread. Look at that. So it's just some kind of twist lock mechanism. Literally half a turn and she popped off. It's loose too. So these aren't chamfered in any way, but you can see the... So I hope you can see the locking mechanism in there. That metal plate that clamps down on the rod there. That might have come off already. Yeah, there we go. So we are now ready to pop this one screw off and slide the circuit board out. Short that big capacitor because it scares me. So here's the plastic shell. This display dial assembly is completely part of the circuit board, as it were. Oh boy. Would you have guessed that this was hand assembled? So here is our tuning knob, and we can see a pulley there, some sort of pulley mechanism going up back to the big electromechanical thing that we'll explore later. This is the knob that I thought could be related to high and low pass filtering, and actually, as you can see, this wire here goes all the way back to here is the input, and here is the other side of this big blobby thing. So this is, I am assuming, a transformer. It's got some kind of, yeah, you can see a little tiny copper wire there. So there's going to be some windings in this plasticky, well, not plastic, maybe wrap thingamajig. And we've got another coil on here which goes out to the speaker. Can you tell this thing was hand built? Oh, how did you end up there? There we go. And this one is the volume knob, which is tapped off 1, 2, 3, 4, 5, 6. There's pretty much, this is basically a open air circuit. They have, if they've needed to run a wire, like this is the power coming in, probably AC. There's 1, 2, 3 wires and a I really need to be careful with this thing because we have these valves are in sockets, which is nice because we can just replace them if necessary, but I would rather not damage them. So I have done some research, and essentially the interference that it's getting, it can come in through the AC lines. Essentially the AC lines, everything metal is always acting as a big AM antenna. It could be coming in through the lines, but it can also be radiating out of the lines. Modern LED lights, for example, have a switch mode power supply, and that can create, if it's poorly designed, it can create EMI interference that feeds back into the lines, but essentially it radiates out of the lines as that same electromagnetic interference. So to test whether it's worth installing this capacitor at all, or whether we just leave this as it is, I'm going to plug this into a UPS, which means it is fully isolated from all other electronic devices. Now I just wanted to give you a quick look at this tuner mechanism here. If we see, there's the string that's connected to the knob here, goes over this big pulley, and the tuner, the frequency is indicated by the dial, which is on the front of the whole stack. Essentially this is a big stack of plates, 2 big stacks of plates, and when I turn this, more or less of those plates are in contact with each other. So in this way, this whole electromechanical assembly here is acting as must be a very high current potentiometer. I'll get it reassembled and get the UPS set up, and we'll see how she sings. So I've now got the Gloria going again, and with everything that was attached to the UPS, so a computer, a couple of speakers, it's now a lot clearer. It's making a little crackle every now and then. But even with this filter, it's pretty clear. So now I'm going to try turning the UPS off at the wall. So immediate change there. You can hear the 50 Hz buzz quite clearly. So there may be some interference coming in through the power line, but given how clear it is, here we're back on AC power from the wall. So thanks for watching this video. It ended up being quite a deep dive into the internals of the Gloria. I just wanted to make a quick follow-up mentioning this website, vintageradio.co.nz, which I've linked down in the description. This is their page for the Dominion Radio and Electrical Corporation. And it looks like the Gloria that we took a look at was actually their very first model, and then they continued producing radios all the way through until the 1960s, the late 60s, with the transistor era. So if you're interested in checking that out, check the link in the description. If we go into the page for our model, we can see an original print ad, which is pretty cool to see. A bit about the generic Australian case that they used. And we've got a full hand-drawn circuit diagram, which is pretty cool to see. One thing I thought was kind of interesting is the way they've used so many voltages. So this is the transformer that we had a look at, and then this is a full bridge rectifier, but there's also a 6-volt winding on that transformer, which goes to a lot of all of the valves actually. So I believe that that's probably something to do with powering the tube itself, because vacuum tubes are actually light bulbs, which if you've seen the Veritasium video, but then the rest of it is powered by 220 volts DC, which is kind of a terrifying voltage. And then there's all over the place 27 volts, 45 volts, negative 9 volts, 50 volts, 4.25 volts. So yeah, check that out if that's your sort of thing. So yeah, if you like this video enough to watch it all the way through, why not subscribe? I thought I might try making a crystal radio myself to try and get started learning electronics. So if you like that sort of thing, get subscribed. And if you like this video enough to watch it this far, why not like it as well? Cheers!